Okay, 5.2b is domain and range, but this time we will be using interval notation. So domain and range can be discrete or continuous. A discrete domain and range can be written as a list. That's the domain we've done so far. These two have discrete domain, and we do already know how to do these. So for this first relation, they're listed, it's a list of ordered pairs. So the domain is all the x values, which is the 1, the -5, the -11, and the -5, but I am going to put them in order and exclude any repeats. So my domain is -11, -5, and 1, and you are welcome to use the curly brackets. If you leave them off, I'm okay with that too. Okay, range is the y-coordinates, so 3, 7, 3, 7. So 3 and 7 because I excluded the repeats. And my domain and range is just a list of values because this is a discrete relation. Okay, for the graph, the same. This is 5 points, so I should be able to list the domain and range as a list. Okay, I'm going to go ahead and label the ordered pairs. Although you don't have to label them, at the end I'll show you how you might do it without labeling. Okay, the x coordinates are the -2, the -1, the 0, the 1, and the 2. And I do put them in order, and I do exclude the repeats. The range is the y coordinates. I have 4, 2, 0, 2, and 4. Okay, if it doesn't tell you to write the ordered pairs, you don't have to write the ordered pairs. I could just look at the x values for each of these points to get the domain. So for this one over here, the x is -2, -1, 0, 1, and 2, which matches this. The y coordinates would be 0. These have a y coordinate of 2, and these have a y coordinate of 4, and I could just find the domain and range by analyzing the graph. Okay, now we're going to switch to continuous graphs. Okay, a continuous graph is one that's connected. So this is continuous because it's connected. I can't list all the points of this relation because there's too many points. There's millions and millions of points along this little teeny line segment. Okay, continuous domain and range can be written using interval notation. Interval notation is a different way to represent an inequality. If you recall from last class, interval notation, we do the minimum or the lowest value, comma, the highest value. We use parentheses to represent open circles and to represent infinity, and we use brackets to represent closed circles. So for the first couple examples, we're going to kind of scaffold all the steps, and then we'll take out some of these steps as we work. Okay, this is my continuous graph. I'm going to find the domain and range using interval notation. For the domain, remember, domain is the x's. So I'm going to look at the graph and look for the minimum x value. The x-axis goes from left to right. The minimum x value will occur at the point that is furthest to the left. So if I look at this graph, the point furthest to the left is way over here. Because I'm doing domain, I care only about the x value at that point. So at that point, the x value is -5, because it's -1, -2, -3, -4, -5. At -5, this is an open circle, and remember, if there is an open circle, it's a parenthesis. Okay, now if I follow this relation, I go furthest to the right on the x-axis, I get to this point here. The x-coordinate for this point is going to be 4. Okay, and because there is a closed circle there, this will be a bracket. So to express my domain in interval notation, the x's go from -5 with a parenthesis, comma, 4 with a bracket. And you can see the graph fits between x is -5 and x is 4. Now the range is the y values. So I'm going to start with the minimum y value. The y-axis is this one. So the minimum y value will be at lowest to highest. So the lowest point on this graph is this point right here. This time I only look at the y value. The y-coordinate of this point is -3. And because it was an open circle at the lowest point, this will be a parenthesis. The maximum y value is at the highest point on the graph. The highest point on the graph is way up here. Okay, the y-coordinate at that point, y is 4. And at that highest point, it is a closed circle, so it's going to be a bracket. So to express my range in interval notation, it's going to be parenthesis -3, comma, 4, bracket. Okay, let's try some other ones because this is a little tricky. Okay, let's look at example 2. Okay, this is continuous because it's connected. It's not a bunch of little dots. Okay, remember domain is the x values. The x-axis goes from left to right. So I want the furthest left point to the furthest right point of the graph. Okay, on the graph, the furthest left point is way over here, but actually this is an arrow. Okay, if I'm going left forever, I'm going towards negative infinity. So the minimum x value is actually negative infinity. Because this is infinity, I automatically know this is going to be a parenthesis. Okay, the furthest right point is going to be over here. Okay, the x value at this point is 2, and because there is an open circle there, it will also be a parenthesis. So my domain is parenthesis negative infinity, comma 2, parenthesis. Now I'm going to look at the range. Range is the y value. So I want to go from the lowest y value on the graph to the highest y value on the graph. So looking at this graph, the lowest point on the graph is down here. Okay, it's an arrow again, and it's going down. So this is still negative infinity in the y direction because it's going down forever. Because it's at infinity, it's automatically a parenthesis. Okay, the highest point on the graph is this point right here. Okay, the y value of that point is actually 0. And because it's an open circle, it's a parenthesis. So my range in interval notation will be parenthesis negative infinity, comma 0, parenthesis. Okay, we're going to do some more examples because this is a tricky talk bit. We're going to take out some of the intermediate steps and jump straight to the domain and range, and we'll see if we can get the hang of it. Okay, for example 3, this is continuous because everything's connected. Remember, domain is the x's. X-axis goes from left to right, so the furthest left point on this graph is over here. The x value at that point is negative 4, comma. Because this is an open circle, I'm going to use a parenthesis. Now the furthest right point on this graph is way over here, but that's not actually a point, it's an arrow. It's going to the right forever. Since it's going to the right forever, that's infinity. You could also write positive infinity because it's going in the positive direction. Because it's infinity, it's automatically a parenthesis. Okay, now consider your range. Your range is your y values. Y values, the y-axis is the vertical axis, so lowest to highest. The lowest point on the graph is this point. The y value at this point is negative 1. Because it's an open circle, it's a parenthesis. Okay, the highest y value on this graph is way up here, but that's not actually a point, it's an arrow. So it keeps going up forever. Going forever is infinite, so it's infinity. Since it's going in the positive direction, it's positive infinity, or we can just write infinity. Infinity always has a parenthesis. So that's my range. Okay, let's look at example 4. That's my continuous function because it's connected. Okay, domain is the x's, so in the x, along the x-axis, left to right, I want the furthest left point, which will be way up here. The x value of that point is negative 3, and because it's an open circle, I parenthesis. The furthest right point is this one. The x value at that point is 3, and because it's open, I use a parenthesis. And if you look at this graph, it does, the x's stay between negative 3 and 3. Negative 3 to 3 holds the graph. Range is the y's. In interval notation, I go from the lowest y value to the highest y value. So the lowest point on the graph is over here, this point here. The y value of this point is negative 2, and it was an open circle. The highest y value is up here to the 4, open. That's my range. The range goes from y is negative 2 to y is 4. Okay, let's do 2 more. Okay, example 5 looks kind of crazy, but as long as you focus on just the lowest and the highest values, it's the same idea. Remember, domain is x, x-axis left to right. So the furthest left point is actually this one here. And the x-coordinate here is negative 3, and it's a closed circle, so I'm going to use a bracket. Now there's a bunch of points along this graph, but I only care about the one that is furthest to the right. So the furthest to the right point is way over here. The x-coordinate here is 9. And because it is a closed circle, I use a bracket. Okay, now the range is the y values. And again, there's a lot of things going on in this graph, but if I focus only on the very lowest y value and the very highest y value, I'll still get the correct range. Okay, the lowest point on the graph is this one. Okay, the y value of this point is -3, and it's a bracket because it was a closed circle. Okay, the very highest point on the graph is way up here. The y value of this highest point is 6, and it is a bracket because the graph passes through there. The only reason it would be a parenthesis is if there was actually an open circle there or an arrow there. Okay, let's do one more example and then you'll try it on your own. Okay, domain X. Furthest to the left is this one. And it has a bracket because it's a closed circle. Furthest to the right is this one. And it has a parenthesis because it's an open circle. Okay, range is the y's. So the lowest y value is way down here, which is -5, and it is a bracket because it's a closed circle. The very highest y value is way up here. This graph goes all the way up to y is 3, and I am going to use a bracket because it passes through that point. Okay, go ahead and do the practice problems. When you're done, check the calendar for the solutions to check your answers.